If you haven't slept properly in the last 24 hours, your body has already started breaking itself down. Not in some abstract long-term way. Right now, at a cellular level, most people think sleep deprivation just makes you tired and unfocused. That's true, but it's also the least interesting thing happening. Because underneath that exhaustion, your body is running a process called autophagy, where your own cells begin consuming each other. This isn't damage from the outside. Your body is doing it to itself. Autophagy is normally a good thing. While you sleep, your cells break down and recycle damaged proteins, clear out debris, keep everything running clean. It's essentially your body doing maintenance when the building is closed. But skip sleep, and that process loses its regulation. Scientists discovered that sleep deprivation causes autophagy to spike aggressively in the brain, specifically in regions that control alertness and movement. Your brain, denied the restoration it's built around, starts cannibalizing its own tissue at an accelerated rate. The cells keeping you functional become fuel. And while that's happening, your immune system starts doing something equally destructive. It launches an inflammatory response, full scale, even though there's no infection, no injury, nothing to fight. Researchers at UC Berkeley found that a single night of poor sleep is enough to cause a significant spike in inflammatory markers, the same ones linked to heart disease, diabetes, and accelerated biological aging. Your body reads the absence of sleep as a threat and responds accordingly. The problem is it has nothing to attack, so that response turns inward. Then your gut gets involved. The lining of your intestinal wall, the barrier that keeps bacteria contained inside your digestive tract, begins to degrade. Bacteria that are supposed to stay in your gut start leaking into your bloodstream. This triggers another immune response on top of the one already running. More inflammation, more internal damage, compounding in real time. And here's something most people don't expect. That gut-brain connection runs both ways. The bacteria in your digestive system communicate directly with your brain through the vagus nerve, a pathway so significant that scientists have started calling the gut a second brain. When that barrier breaks down and the bacterial balance shifts, the signals traveling up that pathway shift too. Mood, anxiety levels, even cognitive clarity, all of it influenced by what's happening in your gut. Sleep deprivation doesn't just affect your brain directly. It corrupts the system that was helping regulate it. But the brain itself is where the consequences get hardest to ignore. There's a system in your brain called the glymphatic system, a network of fluid channels that's only fully active during deep sleep. Its job is to flush metabolic waste out of your brain tissue. Cerebrospinal fluid pulses through, clearing everything out, including a toxic protein called beta amyloid. Beta amyloid is the same protein that builds up in the brains of Alzheimer's patients. Every night you sleep properly, your brain clears it. Every night you don't, it accumulates. Researchers found measurable increases in beta amyloid buildup after just one night without adequate sleep. Not after years of poor sleep. One night. That's not a long-term risk sitting somewhere in the future. That's an immediate consequence with a physical trace left inside your brain tissue. By hour 24 without sleep, something shifts in how you perceive the world around you. The prefrontal cortex, the region responsible for rational thinking, impulse control, and measured decision-making, begins losing its ability to regulate the amygdala. The amygdala is your brain's threat detection center. Under normal conditions, the prefrontal cortex keeps it calibrated. It's the part of you that says, this situation is not actually dangerous. Without sleep, that regulation weakens. The amygdala becomes hypersensitive, and the prefrontal cortex, running on diminishing resources, can no longer pull it back effectively. Studies have shown that sleep-deprived subjects consistently misread neutral facial expressions as hostile. A blank face becomes a threat. A normal interaction feels loaded. The brain, exhausted and inflamed, starts interpreting the world through a filter of low-level threat that isn't there. Psychologically, it begins to resemble a mild paranoid state. And because the prefrontal cortex is also where self-awareness lives, the person experiencing this usually doesn't notice. They feel justified in their reactions, certain their judgment is fine, convinced the problem is external. Your brain becomes a poor judge of how impaired your brain is. By 36 hours, the hormonal systems start to unravel. Leptin, The hormone that signals to your brain that you've eaten enough drops sharply. Ghrelin, the hormone that drives hunger, surges in the opposite direction. The result isn't just increased appetite. Sleep-deprived people specifically seek out high-calorie, high-sugar, high-fat foods. The brain, scrambling for energy it can no longer produce efficiently, starts treating food as a substitute for the restoration it was denied. The problem is that the decision-making circuits that would normally moderate those impulses are already compromised. The prefrontal cortex, already struggling, can no longer override the cravings the way it should. So people eat and feel worse, and the inflammation already running through their system gets additional fuel. Scientists have also found that insulin sensitivity drops significantly after sleep deprivation. The body becomes less efficient at processing glucose, the same mechanism seen in early-stage type 2 diabetes. Not after months of poor sleep, after days. The metabolic system and the sleep system are not separate. They are deeply structurally linked. Disrupt one and the other begins to fail alongside it. By 48 hours, the body starts doing something that reveals just how fundamental sleep actually is. Microsleeps begin. These are involuntary bursts of sleep lasting anywhere from a fraction of a second to 30 seconds. The person experiencing them is often completely unaware they've happened. One moment they're awake, the next a sliver of time is simply gone. This is the brain forcing the issue. It cannot sustain wakefulness indefinitely, and it will not try. It takes sleep in whatever fragments it can find, regardless of whether the person is driving, operating machinery, or mid-conversation. It doesn't ask permission. By 72 hours without sleep, the brain begins generating hallucinations. Not because of any external substance or neurological disorder, but because REM sleep, the stage characterized by vivid dreaming, is so essential to brain function that the brain starts producing it while the person is still technically awake. The boundary between sleeping and waking begins to dissolve. Voices, shapes in peripheral vision, patterns that aren't there. The brain, denied the experience it requires, manufactures it unilaterally. It creates the very thing it was refused. What's striking about this isn't just how extreme it is, it's how fast it arrives. 72 hours is 3 days. Most people have gone that long with heavily disrupted sleep at some point in their lives. New parents, students during exam periods, people working extended shifts. And most of them had no idea their brain was operating that close to a threshold that produces psychosis-like symptoms. The margins are narrower than almost anyone assumes. And then there's the part that most sleep research doesn't emphasize clearly enough. The majority of this damage, the inflammation, the beta amyloid accumulation, the hormonal disruption, the emotional dysregulation, doesn't fully reverse with one recovery night. Some of it does, but chronic mild sleep deprivation, the kind most people live with without thinking of it as a problem, creates a cumulative deficit that one good night doesn't erase. Studies tracking people through recovery periods found that cognitive performance, reaction time, and emotional regulation didn't return to baseline even after several nights of normal sleep following a period of deprivation. The deficit persists longer than the tiredness does. Most people use how tired they feel as their measure of how sleep-deprived they are. But the research shows that subjective feelings of tiredness plateau and then level off, even as objective cognitive impairment continues to worsen. People stop feeling as tired. They assume they've adapted. They haven't adapted. They've just lost the ability to accurately perceive how impaired they are, which means most people are navigating their lives with a level of accumulated damage they can't clearly measure, because the very faculties they'd use to notice it are the ones most affected by it. Your brain is a poor judge of how impaired your brain is.